What is the scientific method, and why is it important? Hello guys. Welcome to the Evolving Knowledge channel. Today we will answer these questions and show how the scientific method is responsible for the advancement of science. Let's get started. First of all, let's think, what is science? Science is an organized approach that builds and organizes knowledge through testable explanations and predictions about the universe, and about the scientific method. What is that? Any knowledge to be considered science must go through a validation process. This validation process is called the scientific method. In other words, this method is the process of establishing facts through testing and experimentation. It is used in all sciences, including chemistry, physics, geology, biology, and psychology. The invention of the scientific method is attributed to Descartes, but its roots lie a little deeper in two thinkers, Roger and Francis Bacon. Roger Bacon was one of the first academics at Oxford and the first to advocate experimentation as a source of knowledge. He was responsible for what was to become the foundation of empiricism, the idea that reason and knowledge should depend not only on faith but also on our senses because we can learn what we've experienced. Francis Bacon, however, was the one who laid the foundation for what would become Descartes' modern scientific method. Whenever a scientist proposes something new, he must follow the basic steps to give credibility to what is being discovered. But what are these steps? The first one is to make an observation. It is the moment when the researcher observes a particular phenomenon. For example, the ice melts when we increase the temperature of the system. The second step is when the questions are asked. Why does ice melt? Has the mass of water changed? The third step of the process is the proposition of hypotheses. For instance, one type of hypothesis would be, perhaps a chemical reaction is happening. Maybe a different rearrange of atoms. It is worth mentioning that the hypothesis is not necessarily the correct explanation of the phenomenon, it could be wrong. In this example, we know that ice melting is not a chemical change but a physical one. The next phase is to make predictions. Let's see. If I increase the temperature above 0 degrees Celsius, the ice will melt. The fifth stage is when we perform experiments. Let's see at which temperature the ice starts melting. What was the final temperature? The sixth and final step is to iterate. Basically, the scientist will reflect on the results after the experiment is concluded. Results can usually be repeated for double-checking, and if they make sense, variables can be changed. If the hypothesis is not confirmed, new views can be made and return to the process of predictions, tests, and iterations. These iterations are what make the knowledge built. Often it can even be done by other research groups that have read some publication of your experiment and try to replicate them, make new hypotheses, and change the approach. These iterations are what make the knowledge grow and make them be considered science. Hey guys, we are at the end of another video. Tell us in the comment box if you enjoyed it. Before you go, please like this video and subscribe to the Evolving Knowledge channel. Thanks for watching, and see you next time.